Given segment TK bisects angle HKN and angle HTN, tell me what triangles are congruent and why. So where would we start here? Let's add a symbol to our picture. We know. So, sorry about that. Was everyone okay with the warm-up? So when you see bisector, you get to add arcs. It's bisecting two different angles, so you get to add arcs on two different angles. And then you get to put a tick mark on the shared side. And then you're like, why is segment HN even drawn there? I don't know, just to trip us up. And so then triangle THK is congruent to triangle TNK by angle, side, angle. Yay! Okay. So page 1 of your homework answers is right here. So go ahead and check your answers. If you did the shorter assignment, that's fine. Go ahead and check those. Okay, so we were able to look at any questions on 1 through 12? Let's look at 13 through 26. I was asked about on number 16, could it be angle 1 is congruent to angle 4? Absolutely not. So look at number 15 and number 16. Those are naming two separate angles. In that picture, when the top is parallel to the bottom, you need to make the letter Z, and you'll see that angle 2 is congruent to angle 3. When the left is parallel to the right, that's when angle 1 is congruent to angle 4. So those are two different questions with two different answers. So you need to be able to tell the difference between 15 and 16 on a quiz. What helps is when you highlight the parallel lines and you make the letter Z, you'll be able to see which ones are the alternate interior angles. For 17 and 20, are there two answers? Yes. For 17, you could have put that angle 1 is congruent to angle 2. And the Y would be if two sides are congruent, then the angles opposite are congruent. I can't fit that on there. And number 20, I don't think there's another answer for number 20. What's your other answer that you're thinking of for number 20? So on number 20, they're asking, could you have said that the triangle is isosceles? No. If those angles are congruent, then you could say the sides are congruent, and then you could say the triangle is isosceles. But you can't go straight from saying the two angles are congruent to its isosceles. You've skipped a step of logic if you go straight from angles to isosceles. You can't do that. Nope. To say it's an isosceles triangle, you have to have two sides congruent. Look at your sheet. That's the definition of isosceles triangle, a triangle with two congruent sides. The definition doesn't say an isosceles triangle is a triangle with two congruent angles. That's not what it says. So we decided that 17 does have two correct answers and 20 does not. 20 has just that answer. Here's the last page, 27 through 36. If you did all of these problems, you're going to be in really good shape for Monday's quiz. Monday's quiz is this stuff. So when you're getting ready, like on Sunday night, when you're getting ready for Monday's quiz, this is the homework to study. This is Monday's quiz. Oh, sorry. Oh, well, that's today's quiz. Wait. Sorry about that. Wrong file. Here we go. So we're going to just barely dip our toes into the pool of proofs. Just barely dip our toe because it's really cold. We're not ready to jump in yet. Tomorrow we'll jump in. So in this class, there's all different proofs out there. There are paragraph proofs, there are flowchart proofs, and there's T-chart proofs or two-column proofs. And those are the ones that we're going to do in this class. So we're going to have a given. Given is the statements that are true. They are given to you, handed to you on a silver platter. Here you go. Then we're going to have the proof. That's like the challenge. That's like saying, hey, can you get from here to here? I challenge you. The proof is what you're trying to reach as your conclusion. So you're going to have statements, and then you're going to have reasons. We've been practicing the reasons since Monday, okay? We're not going to do an algebraic one, though, so we're not going to have to worry about that. But if we did do an algebraic one, we would say, like, to try to get from the given to the proof, we would say, well, first you distribute the 2. Why are we allowed to do that? Distributive property. Then we would subtract this. Why are we allowed to do that? You know, we would say why we were allowed to do it each time. But we're not going to do algebraic proofs. Instead, we're going to do geometric proofs. So, take a look at these steps for building a great peanut butter and jelly sandwich. They're out of order, right? They're out of order. So we need to put them in the correct order, kind of like proofs. You can have all different true statements, but there's a certain order that they need to go in. There's a certain beginning and there's a certain end, okay? So what would y'all want to do first? What should we do first? I think we need to take the bread and the peanut butter and the jelly out of the pantry and get a knife, right? I think we need to get everything out. I think that's the given. What's going to go last? What's the prove? What's the prove? Pretty sure it's going to be eat the sandwich. Now, the given has to come first. The prove has to come last. But in the middle, is there some wiggle room? Like, does it matter if you spread the peanut butter on or the jelly on first? No. So in the middle of your proof, there's always a little bit of wiggle room, just a little bit. We would have to do this next. We would have to do this second to last. And then these two are the ones that I'm saying are interchangeable. So when you're doing a proof, certain things have to be in order, and then certain things have a little bit of leeway. So that's what I was getting at by giving you this example, okay? It doesn't matter if you put the jelly on first or the peanut butter on first, but it does matter that before you eat it, you're going to put them together and actually make your sandwich, and then you're going to eat it. So that one had to come second to last, but the peanut butter didn't have to come third from last. Okay. So this is a two-column proof where we gave you all the statements. All you have to say is the reasons. So these are really easy. They're called fill-in-the-blank proofs, where we've already given you half of the proof. So let's go over this one real quick. Angle D is congruent to angle X. Angle D is congruent to angle X. So we stated that, and guess what the reason is? The reason is simply that it is given. It's kind of silly, but this is how proofs work. All right. DF is congruent to XZ. DF is congruent to XZ. So that's another statement, and whoa, look at that. It was also given. Angle F is congruent to angle Z, also handed to us. Prove triangle DEF is congruent to triangle XYZ. Yep, they're definitely congruent, and what's the reason? Yeah, you've said it. Angle side angle. So that would be the easiest proof I could possibly think up, is right there. It cannot possibly get easier than given, 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 prove. Because we didn't have to come up with anything on our own, okay? Next one. Ooh, there's a little bit more going on in this one. AC is congruent to AD. AC is congruent to AD. Given. BC is congruent to DE. Also given. Oh, now they're going to make us write the next thing. This is kind of silly, isn't it? This is ridiculous. What's the only given that hasn't been written down? We need to write our next given. AB is congruent to AE. also given. And so ABC is congruent to AED by side, side, side. Once again, the easiest type of proof, given, 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 and then prove. Let's try another one. I'm telling you, we're barely getting our toes wet. Remember, we're taking baby steps. Okay, this one has a little bit more to it. RT bisects QRS, given. Sometimes when I use the given, I cross it out so I know, okay, I've used it. Now, here's where your logical thinking comes in. If RT bisects QRS, then what happens? Well, I would go to my picture and I would add arcs. Why am I allowed to add arcs? I would say angle QRT is congruent to angle SRT. Why? Definition of angle bisector. So this is an example where it's not given. So first, an angle gets bisected. What happens when an angle gets bisected? You get two congruent angles. So that's step 2, that the angles are congruent. It was not given. RT is congruent to RT. What's the reason? Reflexive. Angle 1 is congruent to angle 2. That was also in our given. And something happens by angle side angle. What happens? The prove. Remember, you have to end with the prove. You have to end with the prove. Oh, I forgot my congruent symbol. Congruent to RTS. Okay? We're going to do one more really quick, and then you need to begin your quiz right away. Okay, ready? AE bisects BD. Given. What happens when a segment gets bisected? Well, you get two congruent segments. BC is congruent to DC. Why are we allowed to add tick marks? Well, definition of segment bisector. All right. Angle 1 is congruent to angle 2. That was not given. What's that one? Angle 1 is congruent to angle 2. Vertical angles are congruent. Very good. Okay, it doesn't tell us what comes next. What do you think should come next? We haven't used one of our givens. Did you see how I didn't cross out that other given? We need to use our other given. Given. Let's mark our picture. And then we always end with the prove. You always, always, always end with the prove. You just copy it down. ABC is congruent to triangle EDC, and Y side angle side.